Hey, welcome back to Chem 1804.
Yes.
And we are here to explore enzymes and their reaction rate. You should be familiar with enzymes in terms of protease, amylase. Those are enzymes that are found in the mouth. They help you digest foods. And so we are going to take a look at the pH and temperature and concentrations and how they affect your rates of reaction on your enzymes and what they do in the gut, small intestine, and simulate those reactions. Hopefully, we're going to simulate. Not every experiment goes exactly the way that we want them to go. So we're going to look at some reactions using common household products. We're going to look at yeast. And I've done some prep work before we got started today. We have peroxide, and you have some kits that you're working with, and we'll go ahead and take a look at the supplies that you will have and some things that you're going to need to add to this that's not in your supplies list. So you'll have to have some water, and I've already set that aside. Your kit comes with a plastic beaker, but because I don't have hot running water in my lab, I had to heat up my water to 35 degrees Celsius so that I could dissolve my yeast. I pre-weighed out my 2 grams of yeast, so I'm going to put this aside for now. Yours comes with a weigh boat and, of course, my thermometers, so you should have that. You'll need 5 of your pipettes, and I pre-labeled all my pipettes. You'll need your test tube holder and a test tube, your 10 mil graduated cylinder, 50 mil graduated cylinder. I'm moving all my equipment aside. You'll need your scale, balance. Okay, and then you have your 0.1 molar sodium hydroxide and your 0.1 molar hydrochloric acid, which simulates your base and your acid in your gut. You'll have your well plate, and as you can see on the well plate, I have labeled out my catalysis, which is your enzyme that you're going to be working with today at 0%, 25, 50, 75, and 100. Okay, spoon for stirring, my thermometers, and ruler, my forceps. Now you have 2 medicine cups, and in one medicine cup I have my catalase, and the other I have a diluted amount of my hydrogen peroxide, 1.5%. And here I've taken my filter paper, and in part of the prep work I had 2 options. If you're old school like I am, we have hole punchers that were hand hole punchers, and you are cutting out or popping holes in your filter paper that were about 6 millimeters. But if you don't have a hole punch in your house, you can cut out your hole punch into, again, like I said, 6 millimeters in size. And so I want to show you that you can do them in either circular size or you can do them in square size. And to kind of give you an idea, you can see that, no, of course I'm not going to try and put a square inside of a circle or vice versa, but you can see that they're about the same size. What you need to do is to make sure that whether you're using a square or a circle, that all of your samples are going to be approximately the same size. Because this is a home experiment, you want to keep things as consistent as possible. So I wanted to show you that no matter what, whether you're using a circle or a square, the experiment will still work. Okay, so I did use a variety of circles and squares.
The other thing is also make sure, depending on if you do 2 filter papers when punching holes,
that you do separate your filter paper, because there is a difference in what happens to your reaction rate when you put the 2 pieces together and you pop the hole. There is a significant difference in your time. And if you have 2 of the pieces of filter paper together and you try and test the reaction, you will find a difference. So make sure if you cut them together or you pop them together that you take the two pieces apart. Okay, so that kind of gets your prep work together. It's a very easy setup in getting everything together and getting ready to do the experiment. So that goes through your materials, and we're going to start with activity 1, which is your concentration here. So I've labeled everything because keeping track of what you're working with is really important. And so I took a 3% hydrogen mixture, and I put 10 mils of water, and that was distilled water, purified water, with 10 mils of 3% hydrogen peroxide, and that gives me a 1.5% solution. And then I had 250 mils of distilled water. You don't have to use distilled water. It does tell you to just use hot tap water. And I dissolved 2 grams of my yeast solution, yeast. And your yeast comes in a sealed package. Weighed that out, dissolved it, it activates it. And so I set that aside and got everything else ready. So now what I'm going to do is I'm going to create my control, which is 0%, all the way up to 100%, and that's my catalysis. And so to do that, it does walk you through the process, and this is a picture of what it's going to look like. And on page 8, it actually shows you how to get your 0%, which is your control. So you're going to have 0% catalase and 100% water. And so we're going to take and we're going to put in, for my control, 20 drops of water into my first well. So I'll put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 drops of water, 0 drops of catalase, that's my control. Now to get a 25% solution, I'll have 15 drops of water and 5 drops of catalase. And we'll go all the way down the line until I have 100% catalase, which is 20 drops of catalase and 0 drops of water. And I'll do that very quickly so that we can move along. All right, so I have everything set up. You'll notice that if you look in the wells, it's very clear and colorless. And as the dilutions become less and less, the color changes in tune with my catalase. Okay, so please make sure that you have a single piece of filter paper. So the instructions tell us to take our forceps. We're going to dunk it in the first well because I'm dealing with my control. Make sure you get it thoroughly saturated. And you're going to come over here and you're going to blot dry both sides. Okay. Then you're going to take it over to your 1.5% hydrogen peroxide and you're going to take it all the way to the bottom. You're going to start your timer. Your timer, 3 minutes. Did you stop it?
No.
Okay, we noticed that after 3 minutes on trial 1, there was absolutely no movement. If you hit the 3-minute mark and nothing has happened, as you can see, my disc is still at the bottom, you're going to fill in your chart with 0 centimeters per second. You'll repeat this 2 more times. You'll average it and you'll put your rate in distance per time.
Pay very, very close attention to what your depth is.
Okay, we'll repeat the process. Again, make sure you have a single piece of filter paper. We'll do the 25% solution. We're gonna take off, and I should have gotten my other filter out of there. Sorry about that. Okay, all right, I've blotted it both off. I'll repeat the process, take it all the way to the bottom, and begin your time. Okay, at 25%, I got around 50 centimeters per second. So you'll repeat the process for a second and third time. Again, you'll take an average and then calculate your rate.
Now that's just how many seconds it took to rise.
Yep, that was
So that's
47.39 seconds.
okay. And then you're going to average your time. This up here on, I guess I need to make sure I'm pointing in the right spot. You need to double check your depth. I will not stress how important that is. Then that will be what determines your rate of how many centimeters per second.
And that's 20 mils. And if you recall, mils is equal to centimeters in volume as well as in chemistry. Okay, so centimeters is equal to mils.
So cubic centimeters.
Cubic centimeters, my apologies, cubic centimeters.
So be very careful and read the directions. I'm not asking for cubic centimeters here.
All right, so we'll be back in just a minute with activity 2. Good. All right, so I cleaned up all of my previous activity 1, and I started over. So I took a room measurement here, and my room temperature is 26 degrees Celsius. So in activity 2, now we're going to see what the effect is of catalase and the reaction with my hydrogen peroxide, and the reaction rate between the two, and what temperature does to this. So to do that, we are using our room temperature as our control. And so on your data table 2, you are going to do 3 trial runs, and my room temperature being my control at 26 degrees, I'm then going to do 10 degrees below and 10 degrees above, 20 degrees above, and then 30 degrees above my room temperature. So to do this, I went ahead and, so for 16 degrees, to lower the temperature, I'm using an ice bath. So I took a small amount and I went ahead and cooled this down, and I put that in here, and I'm going to do 3 trial runs, and it's the same process again. I want a single piece of my filter paper, and at 16 degrees below, I'm going to saturate my filter paper, dry it off the same way. Blot. I'll drop it in, put it all the way to the bottom, and start my timer. I can tell it's the end of the day. Okay, and I'll go from there. And I will measure how long it takes. So once I do 3 runs of that, because it's easier just to complete the below room temperature. Now, remember, because we're testing the temperature and its effect on the catalase enzyme, all the concentrations of my catalase are going to remain the same. So it's at 100%. Now to get 10 degrees above 26 degrees, which is room temperature, I took my catalase, and because I have a heat pad here, I just heated it up there, and I'll do all 26 degrees at one time. And so I stopped my reaction rate, and it was around 50 degrees for 16 degrees below, and we'll go from there. Okay, and so that's how you do table 2. Yep. All right, so in activity 3, you'll follow the procedure for setting up your wells just like you did for your aspirin, and you will probably want to make a fresh batch of your catalase so that you get the best results. In activity 3, you will be using your 0.1 molar concentration of your base and your acid to test for your pH and to determine whether or not these are effective on your catalase and what acids and bases do. Outside of that, there's nothing real complicated about it, and I didn't figure you really needed me to walk you through putting in drops into wells. If you have any questions, feel free to contact Dr. Alaband or myself. We'll be happy to walk you through this or answer any questions. Outside of that, that's pretty much all you have to do, and I hope you have a great rest of your session. Thank you.